Welcome everyone to Similarity in Right Triangles. This is section 7.4, just in time for Valentine's Day. We're going to go ahead and get started on this lovely topic. Here we have right triangle altitude similarity theorem. And there's a little bit of background information to get through this. This is definitely going to be a multiple part series. So make sure you guys check out all the videos. Fast forward when you need to. But I'm going to do my best to break it down to the most understandable process. Now, here we have a right triangle, and I'm going to highlight the big one here. Okay, so here we have a big right triangle, and if we draw an altitude here, and you can see it drawn as CD, so this is the altitude drawn, CD, okay? This splits it up into an additional two right triangles. Let me go ahead and draw those. So we can go ahead and draw this small right triangle in green, and then this medium right triangle in purple. Okay, so now hopefully you can clearly see that we have a small right triangle, a medium right triangle, and a large right triangle simply from drawing an altitude in our first big right triangle. And you can do this to any right triangle. You can draw an altitude in any right triangle, and this will create three triangles, and we're going to talk about their relationship in just a second. Okay, so let's consider the big right triangle to start. Oops, I'm not sure why I did that. Okay, so the big right triangle, let's compare it to the small one. So first off, all of these have a 90-degree angle. Okay, that's important because when we're talking about similarity, all we need is two angles, and we can call them similar. Because if they have two angles similar, then all three are similar, and then they're going to be similar triangles from that. Okay, so we just need two triangles. So we have one angle. Now we just need another angle that they share, and we're good to go. The triangles are going to be similar. So if we're considering our big one and our little one, notice here that they have the same angle right here. They share that angle, okay? So if you go up to the big one, we can see that that is this angle, and both the green and the blue triangle share that angle. So therefore, the big one, ABC, is going to be similar to the small one, triangle A. Now I got to make sure I label this correct. So A, I start at that angle, and now I need to go to the right angle. The right angle is D and then C, okay? So ABC, I went A. Whoops, actually, no, I went the wrong direction. A, B, C, I got to end on the right angle, okay? So I got to end on the right, I got to go A, C, D, not A, D, C, okay? But those are two, let me change the color. Those are two similar triangles. So triangle A, C, D, because I'm ending on the right angle. Angle C, in this case, my right angle is angle D for the small one. Okay, so that's my first similarity statement. Now, because of angle, that's the reason. So let me go ahead and move this up, angle. Okay, I'm going to erase this. All right, now let's compare the big one and the medium one. They both have a right angle, okay, but what about another angle? Can we find another angle that they share? And the answer is yes, we can. Look, 1, 2, 3. Okay, 1, 2, 3. 1, 2, 3. They both share this angle right here, angle B. They both have that angle B. So therefore, they're both going to be similar based on the angle similarity theorem. So we're going to say triangle ABC, okay, ABC, we're ending on the right triangle, or the right angle. And actually, what I can do is I can say that this angle C is going to be equivalent to my angle A. Because if B is the same as B and D is the same as C, then that means C has got to be the same as A, okay? So just to recap, B and B are the same, D and C are the same, therefore by the third angle theorem, C and A need to be the same, okay? Now, so we need to write this in the same order. So if we're going A, B, C, the 2, so that's going to be the C to the A, B, to the 3 angle, that's B. And then we got to end on the right angle. In this case, my right angle in the medium is the D angle. And again, this is going to be angle-angle similarity. So copy and then paste. Oops, I didn't copy it. Copy and then paste. All right. Now, hopefully you notice that if the blue triangle is similar, the big and the smaller are similar, and the big and the medium are similar, then we're going to say that the small is also going to be similar to the medium. Okay, these two triangles are going to be similar to each other. And actually we can use substitution based on this sequence to show that. But they're also going to be similar based on angle. Well, they have all three angles similar because we know that 1, 2, 3, that's going to be similar. So interestingly enough, if we draw an altitude, okay, then we're going to have three similar triangles just from drawing that one altitude, which I think is pretty cool. Now let's go ahead and get into geometric mean. Now when we're comparing sides of these three similar triangles, something kind of cool happens, okay? So let's go ahead and start here, and then we'll get over to geometric mean after that. So let's get over here. Now in this case, we're going to be comparing the medium. Let me change the color here. What was my medium color? My medium color was purple. Okay. So this is my medium triangle. And then this is my small triangle. My small triangle was green. Okay, so the red is my small triangle. Should have just made it green. And then, why am I doing this? I'm killing myself for no reason. All right. Let me just change it to the actual colors. Okay, so this is my medium triangle. There we go. That makes me feel better. And this is my small triangle. Okay. Now, I'm making a comparison, and as long as I am comparing the same thing on both sides, the left and the right, so if you see here I'm comparing short and long on the left and short and long on the right, the short on top and the long on bottom. As long as I'm doing that, I am completely fine. So what is my short side? I'm making true statements is what I mean to say. So my short side of my medium triangle. So I'm going to look here. I'm comparing the medium on the left. So my short side is SP. Okay? And my long side is SR. So I'm going to write SR down here. Now let's go to my small triangle. What is my short side? Well, my short side is SQ. SQ is my short side. And what is my long side? My long side is SP. Now, I should have mentioned this before, but anytime we have a right triangle, we need to label certain sides. Okay, we're always going to have a short side, a long side, and then the hypotenuse. Okay, and that's going to happen for each one of these right triangles. So if we go here to the big triangle, there's going to be a short side, a long side, and a hypotenuse. And I think it's important to label it like this and not small, medium, big, because we want to distinguish between the size of the triangle and the length of its legs. So this is a short, not small, a long, not medium, and then a hypotenuse. The hypotenuse is always going to be the longest side, but we want to call it the hypotenuse because it differentiates it from the size of the triangle. Okay, so we have short, long, and a hypotenuse. We're going to be using that, and then small, medium, and big for the size of the triangle. So in this case, we're comparing the short and long side, not the hypotenuse, just this, the short and long side. And we notice something here. We notice that we have the same value for the short side of the medium and the long side of the small. This special case is called the geometric mean. Okay, the geometric mean. Now, why is it called the geometric mean? Well, because we have a new situation. If we have a over x equal to x over b, what happens? Well, we learned in our proportions that we're going to cross multiply to solve for x. What happens when we cross multiply? Well, we get x times x on the right equal to a times b, x times x on the left and a times b on the right. Well, let's simplify this further. We get x squared equals ab. To get x by itself then, we're going to have to take the square root of both sides. So we're left with x equals the square root of a times b. And this is always going to be the case for any geometric mean. Any geometric mean, you're going to take the product of something and then take the square root at the end. Okay, so we took the product of A times B, and then we took the square root to find our missing side. Well, that's going to be the exact same case here. Once we have values, it makes it a little bit easier, but we're going to multiply SR times SQ, and that's going to be equal to SP squared. So we're going to take the square root of that, and we're going to get the value of SR times SQ is going to be equal to SP. And that's how we can find one of the sides based on the information it gives. So we have to set up a true proportion. In this case, we set up a true proportion. And then we just cross multiply and solve, and that becomes a geometric mean. I think I'm going to hit these two theorems up in the next video. I think that's going to be the best way to break this down, so it's in sizable chunks. But make sure you guys understand this concept, at least write it down, understand how to differentiate between small, medium, big triangles. Okay, understand how they're similar, and also understand the hypotenuse, the long side and the short side. As long as you guys can label correctly, understand that we have to set up proportions with a triangle size on the left, another triangle size on the right, while differentiating between the short and long side or the different side lengths. If you can understand that bit, then you're ready to proceed to the next video. So see you then.